Now we are going to see the expressions for frequency domain specifications of second order system. First we are going to see the expression for resonant peak MR. First we are considering the closed loop transfer function of the second order system. It is nothing but C of S by R of S is equal to omega n square divided by S square plus 2 zeta omega n S plus omega n square. Already we have studied in the second unit. Now if you substitute S is equal to j omega, then we will get the sinusoidal transfer function. So this is nothing but the sinusoidal transfer function what you obtained by substituting S is equal to j omega. Here j square is nothing but minus 1, then omega square. So you are getting minus omega square, and here you are getting j into 2 zeta omega n into omega plus omega n square. So from this we are taking omega n square common. So here we will be getting omega square divided by omega n square plus 2 zeta into, here you are having on omega n, in the denominator you will be having omega n square. So you will be getting a omega n plus omega n square divided by omega n square, you will be getting 1. Then we can cancel this omega n square and this omega n square. So finally we are getting 1 divided by, we are separating the real and imaginary parts, and we are getting 1 divided by 1 minus omega divided by omega n the whole square plus j into 2 zeta omega divided by omega n. Now we are taking omega divided by omega n as the normalized frequency u. So in the place of omega divided by omega n, we are substituting u, and we are getting m of j omega is equal to 1 divided by 1 minus u square plus j into 2 zeta u. Now m is nothing but the magnitude of closed loop transfer function, and alpha is nothing but the phase of closed loop transfer function. So the magnitude is nothing but square root of 1 minus u square the whole square plus 2 zeta u the whole square. So the square root can be written as 1 by 2. So we are writing it as magnitude is equal to 1 divided by 1 minus u square the whole square plus 2 zeta u the whole square to the power 1 by 2. Now, so 1 to the power 1 by 2 is nothing but 1. Here you are having the 1 by 2 in the denominator. When we are bringing it to the numerator, we can write it as minus 1 by 2. So we are rewriting this as 1 minus u square the whole square plus 4 into zeta square u square to the power minus 1 by 2. This is nothing but the magnitude. Now we are going to calculate the angle. Angle is nothing but tan inverse of b by a. Since expression is in the denominator, you have to put a minus. So tan inverse of 2 zeta u divided by 1 minus u square. This is nothing but the angle or phase. Now the resonant peak is a maximum value of m. So the condition for maximum value of m can be obtained by differentiating m with respect to u and then letting dm by du is equal to 0 when u is equal to ur. Okay. Now since it is a resonant peak, you are taking u as ur. So ur is nothing but omega r divided by omega. It is nothing but the normalized resonant frequency. Now this is nothing but our m. We are going to differentiate this m with respect to u. So dm by du is nothing but d by du of the value of m is nothing but 1 minus u square the whole square plus 4 zeta square u square to the power minus 1 by 2. So this whole can be taken as x to the power n. The differentiation of x to the power n is nothing but n into x to the power n minus 1. So first n is nothing but minus 1 by 2. Then this is nothing but the whole we are taking it as x. So 1 minus u square the whole square plus 4 zeta square u square into minus 1 by 2 minus 1. It is nothing but minus 3 by 2. Now you have to differentiate the term inside. 1 minus u square the whole square is nothing but 2 into 1 minus u square. Then the differentiation of minus u square is nothing but minus 2 into u. Then we are going to differentiate this 4 zeta square u square. Of these 4 and zeta square are constant, and the differentiation of u square is nothing but 2 into u. So 4 into 2 is 8. So 8 zeta square u. So this minus 3 by 2 we are going to bringing it to the denominator, so it will become 2 into 1 minus u square the whole square plus 4 zeta square u square into 3 by 2. So in the numerator you are having 2 into 1 minus u square into minus 2u plus 8 zeta square u. Okay, so already here you are having 1 minus. So you take that minus outside, then so you will be getting, here you are having a 2, here you are having a 2. So minus 4u into 1 minus u square plus 8 zeta square u. So multiplying by this minus, we will be getting 4u into 1 minus u square minus 8 zeta square u divided by 2 into 1 minus u square the whole square plus 4 zeta square u square to the power 3 by 2. So this is nothing but the equation 1. Now we are replacing u by ur in equation 1 and we are equating it to 0. So when you are cross multiplying, this denominator part will go and we will be having only the numerator part. This is nothing but the equation 2. So while cross multiplying, only we are having that numerator part. So 4ur minus 4, here you are having a ur and here you are having a ur, so ur cube minus 8 zeta square ur is equal to 0. Now you are keeping you are bringing ur to the right hand side, so you will be getting 4ur minus 8 zeta square ur is equal to 4ur cube. So here you are having a ur cube and here you are having a ur and ur. So while cancelling you will be getting, similarly this, here you are having a 4, here you are having a 4, here you are having a 8. So you can cancel, so you will be getting ur square. So how it become ur square means, here you are having a ur, here you are having a ur. You can take it common and you cancel, you will be getting ur square. Similarly from here you can take 4 common. So you will be getting 1 minus 2 zeta square. So ur is nothing but square root of 1 minus 2 zeta square. So this is equation number 3. Therefore the resonant peak occurs when ur is equal to root of 1 minus 2 zeta square. So put this condition in the equation for m and solve for m. So this is the equation for m. In this m, instead of u, you have to put the value 1 minus 2 zeta square. Okay, root of 1 minus 2 zeta square. So in the place of u, first you have to replace it by ur. Then you have to substitute the value of ur. What is ur? Ur is nothing but 1 root of 1 minus 2 zeta square. After simplification, you will be getting 1 divided by 4 zeta square minus 4 zeta to the power 4. From this, so 4 zeta, from these two you can take 4 zeta square common. So you will be getting 4 zeta square into 1 minus zeta square the whole to the power 1 by 2. So if you take, if you remove the root, you will be getting 1 divided by 2 zeta into root of 1 minus zeta square. So this is the value for resonant peak mr. So what is resonant peak? Expression for resonant peak mr? Mr is nothing but 1 divided by 2 into zeta, the square root of 1 minus zeta square. Now we are going to find the expression for resonant frequency omega r. Already we have studied that the normalized resonant frequency ur is equal to omega r divided by omega n. So we have calculated omega r. What is omega r? Omega r is equal to root of 1 minus 2 zeta square. So omega So this is omega r. So what is omega n? Omega r is nothing but omega n into root of 1 minus 2 zeta square. Okay. So normalized resonant frequency is omega r divided by omega n. But what is omega r? Omega r is nothing but root of 1 minus 2 zeta square. So by substituting here, you will be getting omega r is equal to omega n into, please listen, this is not omega r, ur. What is ur? Ur is nothing but root of 1 minus zeta square. So what is omega r? Omega n into ur. So you are getting omega r is equal to omega n into root of 1 minus 2 zeta square. So we have found out the expression for resonant frequency also. Now we are going to find the expression for bandwidth. So the normalized bandwidth UB is equal to omega b divided by omega n. So when U is equal to UB, the magnitude of the closed loop transfer function is 1 by root 2 or minus 3 dB. Hence we are equating the magnitude to magnitude to 1 by root 2. We will be getting the expression for the bandwidth. So we are already having the expression for m. So in that m, you are substituting u is equal to ub, and we are substituting and we are equating it to 1 by 2. So while then we are squaring both sides. So when you are squaring both sides, this square root will go. The 1 by 2 is nothing but the square root. This square root and this square root will go, and when we are cross multiplying, you will be getting 1 minus ub square the whole square plus 4 zeta square ub square is equal to 2. So this is of the form a minus b the whole square, and we are expanding a square plus b square minus 2ab plus 4 zeta square ub square is equal to 2. From these two you are taking 2 ub square common, so you will be getting ub to the power 4 minus 2 ub square into 1 minus zeta square minus 1 is equal to 0. Then we are taking ub square is equal to x. So you will be getting x square minus 2 into 1 minus 2 zeta square into x minus 1. This is a quadratic equation, and when we are solving the quadratic equation, we are getting the value of x as 1 minus 2 zeta square plus square root of 2 minus 4 zeta square plus 4 zeta to the power 4. But ub is nothing but square root of x. So we are substituting and we are getting the value of ub. But what is ub? Ub is nothing but omega b divided by omega n. So omega b is equal to omega n into 1 square root of 1 minus 2 zeta square plus square root of 2 minus 4 zeta square plus 4 zeta to the power 4. So this is nothing but the expression of bandwidth.